PCBs in one way or the other are the things that are powering everything. If you could in plain simple English explain me what it is.
In very simple thing, like if you have seen any TV circuit boards, like those are all basically circuit boards.
Can India make this? If not India, then who leads this?
We are very good at single layer. Single layer problem was solved in 1980s. When it comes to two layer, we are also good. When it comes to multi-layer, also to certain extent we are doing, but as a country, we were net exporter of copper. Basically, when the Sterlite plant in Tamil Nadu closed, post that, we became net importer of copper.
This is also one of the barricades for us doing PCB manufacturing because copper is a
This is very big.
cost goes up.
Yeah, there is almost 10 to 20% increase in raw material CCL prices just from last month to this month.
China is the leader in
China is the
PCBs.
leader. They do single layer, they do HDI and everything in between. And an interesting thing is, we were leader once. So what happened after that?
I still don't know if India is at the right place to do PCB right now because of the lead that China has had. We're starting from just knowing the know-how.
Definitely, I think right now we are not in that position, but we are heading in the right direction.
What were the things that they learned that we don't know yet?
There are a lot of things.
Thanks for doing this, Murali. The idea behind doing this podcast was that we wrote about printed circuit boards a while back. I mean, we were, I think, one of the few guys who were interested in understanding how they work, etc. And you replied to one of our threads. Thanks for doing that. Just before going into the whole thing, if you could tell a little bit about what you do, what your company does.
Yeah, so at Lion Circuits, so we build printed circuit boards, we assemble them, and we also source components. So basically we build the entire printed circuit boards, right? So we manufacture printed circuit board, that's our core. So we do that through a a platform approach where a self-service portal through a self-service portal, right? So primarily anybody who is sitting anywhere across the world can order printed circuit boards from India by going to Lion Circuit.
So PCB or printed circuit board is a word that we don't really hear a lot. It's mostly chips. So from whatever little I've read, I've understood that for every kind of electronic item, whether it's a weighing scale or a car for that matter, you need a chip. But to use that chip, you need a PCB.
Yep.
So PCBs in one way or the other are the things that are powering everything.
True.
So if you could in plain simple English explain me what it is.
Right. See, PCB is basically the substrate for mounting any ICs, any semiconductor, right?
What are ICs?
So ICs are basically integrated circuits, right? These are basically the very important things that runs electronics, right? Like anything you see, any electronic device, it's basically run by the semiconductor, right? Like you have all the programming logic and all these things coded in these semiconductor, right? And to mount all these things, right? Because these semiconductor components are very minute, tiny. Sometimes it's it has so much pins to be connected electrically in a very small area that it needs a very complex substrate.
Right.
Like
substrate
or in a very simple word, it's basically like a board where all these different components will be sitting in a place, right? So where all the different wires get connected, right? So if you imagine if I have to give a parallel, right? Like so you have a building and you have bulbs,
right?
And you have your main panel, and there are wires from your main panel to the bulb, right? So if you want to shrink that, like maybe by 1000x or something like that, you have a circuit board, which basically the circuit board is nothing but it carries these wires in terms of in form of a copper track from one place to another place, right? And you have your control panel, which is your like the main input block, like a connector, and then you have bulb, which could be an LED, right? And then if you want to now switch on this LED and switch off this LED, right? In a way, like maybe at a certain time of a day, or maybe if temperature in a room increases beyond a certain degree
Right.
Celsius, and then you want to switch on the LED or something like that.
Right. Right.
These logics will be sitting inside a controller, will be sitting inside some kind of a electronic device. So these electronic devices mostly are semiconductors, which are programmable ICs, right? Or some kind of a business logic, which is basically semiconductor.
Right. So everything that is mounted is on that board.
Is basically on this board. So in very simple thing, like if you have seen any TV circuit boards, like back then you would have seen like those green color big boards, right? Those are all basically circuit boards.
Right.
Yeah.
So, but like, why are they important, or are they important in the first place?
Yeah. So just like how today, like you have, before there used to be these, single story, probably 2 or 3 floors of building, right? Today we have 50 floors, 100 floors. So just like that, even in PCB, right? When you have more complexity, like, so let's say you have a 100-floor skyscraper, right? Just imagine the number of wires that are needed from your control panel to all the floors to get the lights switched on, right? So just like that, now if you compare that with electronics, you have a very small area to do like all the stuff that are needed. Like for example, in a phone, right? It's almost like a 60-floor building. You can compare a 60-floor building to a PCB, which is of 60 layer. So these PCBs will have 60 layers.
The green board is this much.
Yeah.
To the naked eye.
Yeah.
What does 60 layer mean?
Yeah.
60 PCBs or something else?
Yeah. So what you see visually is only the top layer and the bottom layer, right? So what is there inside is basically multiple layers, right? So like in the same phone, in all the phones that we use today, you have like, let's say probably 1 mm or 1.5 mm thick PCB, right? The thickness of this green color board will be around 1 mm or 1.5 mm. And within that 1 mm, there are about 50 to 60 layers, right? Which are basically compressed together into one.
Right.
And each layer is like a floor. So in each floor, you have a lot of electrical connection. So you have a lot of copper trays going around, connecting between different floors, which is basically different layers. So a signal which is in the bottom layer can travel all the way to the top layer through the 60 layers. Right? So it looks very big, like 60 layers, but just imagine, right? Like 1 mm. 1 mm is basically like almost like credit card.
Yeah.
Thickness of a credit card probably is like double the thickness of a credit card.
And that has 60 let's say a phone has 60 layers of that.
Yeah.
PCB.
So in that thickness, like thickness of a credit card, you will have like multiple layers, like 40 layer, 50 layer. So why are these 40, 50 layers needed in the first place, right? So basically, as a lot of electronics keeps shrinking, right? So you have lower.
What do you mean electronics keep shrinking? The iPhone size keeps getting.
Yeah, the iPhone size, for example, an iPhone. If the iPhone size is getting smaller and smaller, or if the entire area, like let's say for example, you need to have certain cameras, and the cameras are getting bigger, and you have a display, and then the effective area that you get for a printed circuit board within the enclosure, within the inside of the
gets reduced.
It get reduced, right? So your floor area is reducing, your effective area is reducing, but the density is increasing, right? So you need to squeeze in more. It's like basically, just like how we are building skyscrapers to accommodate a large density of population in a smaller area. It's basically, it's parallel to that. In this time, basically what is happening is you need to pack a lot of different electronic components, semiconductor components, in a very small area, right? So which means you need more layers. You need like very complex, connections between these multiple layers, right? So these complex connections between multiple layers, maybe some of the connections are only between like second and third layer, right? Not every connection is between all the layers, right? So there are very complex connections that are happening between these, different 40, 50 layers. And that is what is basically making the printed circuit board more and more complex, right? For example, if we take a wearable device, right? Like any wearable device, right? Like a watch, smartwatch. So can you guess like the number of layers of this smartwatch? Like it looks very simple, right? Like for a user, it is basically, it just displays time and it does a bunch of stuff. It's the same thing. It's almost as complex as a phone, except for a few things, right? It can do a lot of stuff now, right? Just the display is smaller. And that basically again calls for putting a lot of different electronics, putting a lot of processing power to be able to do a lot of stuff in that small area. That demands a lot of complex interconnects. So these interconnects are nothing but PCBs.
Right. Now that you've put out that there are multiple layers just in a phone to make that one PCB, it's hard to make a PCB, or like?
Yeah, it's fairly complex. Like it depends, right? Like so, there are PCBs like okay, this is one extreme example, right? So now let's take another example before getting into the complexity part, right? So while phones and wearable devices form one end of the spectrum, the other end of the spectrum is basically your simple remote,
remote.
TV remotes. TV remotes are typically single layer boards, right? These, now maybe it has evolved to 2-layer max, but it used to be mostly single layer because it's very simple. It does like very, simple job. But even the TV remote has a PCB inside, right? Basically just connecting all the, keypads, like the number 1, 2, and all that stuff to the battery. And then it emits a certain IR radiations, which the TV can understand, right? Even a TV remote has a semiconductor, right? So it basically encodes a lot of IR rays so that only the TV understands what it is communicating, right? When you change a channel or when you want to increase the volume, right? So in this case, it is a single layer board, meaning it's just one floor, right? There is basically a dielectric material, which is a non-conductive substrate, and then you have one layer of conductive substrate, right? So this is very simple. And in India, we are doing this board, these kind of single layer boards, from probably around early 1980s, right? There is a huge spectrum from very simple single layer to most complex, like what we call as a smartphone PCB HDI boards. So in this entire spectrum, it depends on where a particular factory is operating.
What do you mean by that?
Yeah, what it means is basically if somebody is getting into PCB manufacturing, right? So it depends on a couple of things, right? Does that particular PCB manufacturing company, the factory, how many layers are they building, right? If it is single layer or 2-layer, right, it is one category. Single and 2-layer it doesn't need a lot of complexity to build circuit boards. Single layer is very simple. There are a lot of companies in India who can do single layer boards. Very low margin and very low cost PCBs. Next, you come to double layer, 2-layer. 2-layer, number of players in the current Indian market are less compared to single layer, but it is not very complex. It's doable. It's it needs to go through a lot of different chemistry to connect. So here the most complexity, like, when I say complexity, right? So let's define complexity. What are the complexity? Where are some of these complexities coming from? So when you take a double layer, 2-layer PCB, you have the ground floor, you have the first floor, right? You need to make a connection between the ground and first floor, basically a staircase, right? To construct this staircase in terms of a PCB is basically connecting the top layer conductive surface to bottom conductive surface, which is called a plated through hole. A hole which is plated to be able to conduct from top layer to bottom layer.
Got it.
Basically, so that it can conduct electricity, right? So in order to do this, this is the process which adds complexity, first layer of complexity, right? So if a particular factory is doing this, then they have at least know how to do a plated through hole process, and it adds certain complexity. It needs certain type of machineries. Depending on how large the facility is, they can do highly repeatability. You can control the repeatability, the quality of these connections between the different layers. They can control based on what type of machines they have.
Right.
So the next segment in the spectrum is basically multi-layer boards.
Right.
Typically, in most of the current scenario, it is also referred as MLB, multi-layer boards, basically. Right? Somebody who is layman to this, if they see MLB, it's basically nothing but a multi-layer board, which basically is nothing but more than two stories of building.
Right.
So if you have more than two stories, it is multi-layer board.
More than one floor is basically.
More than one floor is double layer. More than two floors, multi-layer. Right. So why this multi-layer is considered as the next step in the spectrum is mostly because you have inner layers. So inner layers get introduced in this particular in this category. Right. So what it means is now you don't only have the top layer and the bottom layer, but you also have layers which is inside, which is hidden, which you cannot see visually. Right. So manufacturing these will need more machineries, different types of machines. Right. Basically, where you will do the inner layers separately, right, and then the all the inner layers together are packed together, and then you process the final as a two-layer board. So finally, it becomes a multi-layer board, right? So you can have like either 2-layer, 4-layer, or 6-layer, 8-layer. It goes in multiples of 2, typically, because when you take an inner layer will again have a top and bottom, right? So that's why it goes in multiple of 2, typically, right? So you have 4, 6, 8, 10, 12,
right,
like that.
So the inner layers will also keep.
Inner layers will keep increasing.
Right.
Got it. So this category, this segment is called multi-layer boards. So in multi-layer boards, because it needs more complexity, it has more complexity, it needs different types of machines, and it needs different know-hows. There are a lot of know-hows in these things, like processes.
What do you mean by know-how?
Know-hows in the sense, for example, typically anybody who runs a PCB industry, right, they'll know that if somebody is doing only single layer, they are limited to that knowledge, right? If they are doing double layer or multi-layer, any process, like for example, you need to create tracks on the surface, right? Basically, to create tracks on the surface, it's basically, in a very simple term, it is photolithography.
By the track, do you mean the upper layer of the circuit board?
Yeah. So by tracks, what I mean is upper layer and also all the inner layers, wherever a connection has to be made, right? In each layer, you need the wires like from one side of the board to other side of the board. And there might be multiple wires on each layer, right? So these are basically called tracks, PCB track, right? A track on a copper surface, basically, right? So when these basically tracks are, achieved by using photolithography.
Okay. What's
Photolithography in a very simple way, if you have to explain, is basically if you have a circuit design, right? Like circuit design is nothing but all these wire interconnections are designed in a tool, in a tool called a CAD, like just like in a PCB software. There will be softwares where you design. Okay, I want a connection from this point to this point, and this connection has to be of a certain width, of a certain shape. It has to go from here to here. Depending on various complexity, this can be very simple or complex. Even the design.
Right.
Design itself can be very complex also, right? So, but essentially, what we are doing is basically determining what should be the path of the wire,
right,
and what should be the thickness or width of the trace.
Got it.
So once all these things are determined, you will have like a pattern. We call that as a circuit pattern on a particular layer, right? So this pattern has to be printed on the circuit board, basically on one of the layers.
Right.
What we mean by printed on a particular layer is that you have a copper sheet. That copper sheet, you need to convert that plain copper sheet into tracks and no tracks, right? So wherever you have the connection, wherever you need the connection, you keep the track. Wherever you don't need the connection, you need to remove the copper. Right? So to remove the copper, we need to first print the pattern onto the copper.
Right.
That is done through something called a photosensitive material. We use a photosensitive material, and using that photosensitive material, we basically apply the photosensitive material on the copper, and then put the pattern, image of the pattern onto the
copper sheet.
On the copper sheet, yeah, on top of the photosensitive material. And then using some processes, like using something called etching process. Etching process. So these are chemically etched, meaning wherever you need the trace, you will have the copper. Wherever you don't need the trace, copper is removed through a chemical process. Like typically ammonia is used. Right? Ammonia reacts with copper,
right,
removes the copper,
yeah,
right? And basically we get the pattern, circuit pattern.
Right. Interesting.
Now this is basically one layer. All right.
This has to be done.
This has to be done for all the layers.
Right.
And finally, it has to be connected, all pressed together.
Okay.
And then again, like the staircase that I was telling, right? The final one from the highest floor to the lowest floor
has to be connected. Right. Got it.
Right. Now, when you do that, you can't see the inner layers. Right. So what we call as how accurately can you, we call that as a registration, right? Like layer registration. So from one layer, the top layer to second, third, fourth, fifth, how well can you manage to place all of them together in a way that when you do the final connection from the top layer to the bottom layer, it all matches, right? Otherwise, your circuit is gone. Like let's say when you're building, right? Like let's say your second layer is in the same position where you wanted it to be, but you are the next layer, right? The second and third is one layer, fourth and fifth is another layer. So your fourth and fifth layer, if it is moved by like let's say even 50 little bit, like 50 micron, right? 50 micron
is nothing
but like your hair, like the thickness of hair is basically about 100 micron.
Oh, okay. 15 micron is
50 micron is basically half of that, right? Like, so in that 50 micron, if it moves by that much, your entire board is gone. Your entire circuit board, you have to just throw it. After you place all the board, if you come to know that, okay, it's moved by a 50 micron,
right?
You just have to dump the raw material is wasted.
Right.
This is a multi-layer board. We have not even come to the fourth segment, which is basically high density interconnect.
High density interconnect.
Yeah. So we started with single layer, double layer, multi-layer board, MLBs, and then HDI.
Okay.
HDI is high density interconnect board. What is the main difference between HDI and multi-layer? HDI board is also a multi-layer board with more complexity.
Okay, what more?
Yeah. So now imagine you have this skyscraper. In a skyscraper, let's say you have certain floors which are dedicated to a particular tenant, right? Like let's say, for example, you have a duplay or a three-play kind of a home within your skyscraper. That is only dedicated, those stairs between these multiple layers
Is
floors
dedicated to
is
that house.
dedicated to only one house, right? So similarly, even in PCB, we have few we call it as blind and buried vias.
Wires.
Via.
Oh, via.
Via is nothing but a connection from one layer to another layer. Okay. It's called a via, which is nothing but a plated through hole.
Okay.
So this via, if it is between only a inner layer, let's say, I'll give you an example. Let's say we take a 6-layer board. 6-layer board will have your first, second, third, fourth, fifth, and sixth. So your second, third, fourth, and fifth is basically inner layers, right? Your first layer is outside, sixth layer is outside, right?
Yeah.
Correct, no? Yeah. In the inner layer, if you have a via only from your second layer and your third layer, right? It's a buried via.
Okay.
Because it is buried.
Oh, okay.
Right? In a simple term, it's buried inside.
Right.
Meaning, if there is a via connection between second and third, and you complete the PCB, you won't even see on the top that there is a hole inside the PCB, right? So, and then you have, that is a buried via, and then a blind via. Blind via is nothing but, let's say there is a via connection between your fifth layer and sixth layer. Sixth layer, because it's outside, you can see the hole, but it stops at a certain distance, right? Like it stops at fifth layer. You will not know where it stops. It's like in the design, it stops at fifth layer, right? Once the board is finished, you can't make out visually, right? So these are called blind vias.
But what's the, sorry to cut you, but what's the point of these things? Yeah.
See, as I was telling, like in our first conversation, we discussed about the board area getting shrinked and that causing a lot of real estate problem on the PCB, right? So that real estate problem is solved by creating these complex structures so that the entire area which is on top of these holes are utilized for some other purposes. So now imagine, so you have a buried via. Now on top of the buried via, you can run a track. You can run a wire on top of a buried via without disturbing the inner via. That floor space, that real estate on the PCB has become so expensive, right? Even a small, as small as 0.15 or lower. Some of these vias can be as small as 1 to 2 mil, right? 1 to 2 mil is basically, 1 mil is 0.25 microns. 0.25, basically 25 microns, 0.25 mm, right? 25 micron is the size of these holes. So in order to make a 0.25 micron hole, right, you need laser drills. You need a laser machine,
specific precision.
very specific machine to even make these holes. These are not available in all these other factories.
Even the multi-layer.
Even the multi-layer doesn't need a...
But where is HDI, all these kind of things used?
In all the phones, pretty much any phone you take, any wearable, these are all HDI boards.
And multi-layer?
Multi-layer would be typically, let's say, your engine control unit. Right. Like in any car, everything is driven by electronics.
Right.
It's all fly-by-wire, right? Like drive-by-wire, right? Like even in aircraft, it's fly-by-wire now, right? Like, so in anything in car, right? Like mostly is all interconnected by electronics, right? Like it's all communication, like the engine control is by electronics, and these kind of engine control are mostly multi-layer boards.
Got it.
Very less, in only few places HDI boards are used, but most of the automotive segment does it away, we do it with multi-layer. But there are also certain areas in automotive where HDI boards are used.
Okay, I have a couple of questions. We discussed how, more or less, how a printed circuit board is made and the complexity behind it. The first question that I have is, can India make this? And sorry, related to that, if not India, then who leads this and how does the whole supply chain look like? Because I think there are many things at play here to just make that one board.
True. So in all this complexity, right, like from single layer to HDI boards, right now, as of today, we don't have a HDI plant in India. There are few companies who can do prototypes,
Prototype, but not scale.
not at scale. But most of the companies are scaling. We are all, as a in our country, we are trying to scale this ecosystem in such a way that we can build HDI boards pretty soon, right? That is where some of the government incentives are also aligned to. Maybe we can come to that later. Coming back to your question about, like, can we build some of these boards in India? What are the things that we can do in India? We are very good at single layer. Single layer problem was solved in 1980s, right?
There is no use now as such.
There are still, even today, there are a lot of applications with single layer boards. Very simple toys.
Oh, right.
Right? The toys, very simple toys still use a single layer board, right? And even in toys, some of the complex toys use HDI boards. That's a different story. Yeah. But there are very simple toys which can be made with single layer, even remotes. And there are a lot of SMPS, the UPS.
What's UPS? Sorry.
UPS is basically the uninterrupted power supply that we use in homes, right? Like when for power backups. Those UPS, basically some of those UPS PCBs are some places single layer, right? So when it comes to two layer, we are also good in India. Meaning, like, when we say we, like, as a country, a lot of factories are there. But when it comes to multi-layer, also to certain extent we are doing. HDI is very bad, right? So as the complexity scales, the capacity in India goes down significantly down. It's not linear, it's like exponentially down. And to a matter of fact, actually, just to give an example, comparison, there are probably around 200 factories which can do single, double, and multi-layer.
200 factories?
200 factories which can do all these, the first three.
Right, apart from the HDI.
HDI maybe one or two. Let's include them also. Like, there are, let's say, 200 factories which can do, like, all these 4 different complexities, right, of PCBs
in India.
Out of that, probably around 150 to 160 will only do single layer. Right? Probably the remaining around like 20 to 30 can do double layer.
Oh, then like it's...
And then like probably 10 people or 15 people can do multi-layer. And then 1 or 2 can do HDI.
That too prototypes.
So you see the, how it changes, right? So let's compare this now with China.
Okay. China is the leader in...
China is the leader.
They are the leader everywhere.
China is the leader in PCB manufacturing, right? And an interesting thing is, we were leader once. Or if you are not a leader, we were leading the segment. We were one of the top, players. India was one of the top players in 1980s.
Right. This is just for single layer.
So just for single layer.
There was no HDI.
At that time, the PCB was not evolved as much.
Right. Needs were also
not there. That was the time when the mostly TV boards, right? Huge, like the TV board used to be like probably like 2 feet by 1 feet or something like that. The PCB, the board was of that size, right? Today a PCB, just to give a comparison, today the entire PCB circuit board will be probably like if you keep 4 credit card size,
Oh,
4 credit cards next to each other, probably it will be size of that, right? So before it used to be like probably 2 feet by 2 feet or something like that, very big. So when the PCB demands, the area was big, we could do it a single layer, complexity less complex, mostly transistor driven, huge tubes and huge components. That time, India, there were a lot of some of the people who had come back from other countries. I have met some of the founders who started PCB factories in 1980s. I was actually very inspired to talk to them and learn their journey. So back then, the stories that they shared, to listen to those firsthand, like, was very inspirational, because some of the words that they were saying was, that time, some of them, like one of them basically set up the India's first fully automatic single layer processing unit in Bangalore.
yeah.
Right?
1980.
1980s, mid 1980s. This plant, basically they set up the India's first fully automatic single layer processing line, right? Unfortunately, they shut down the entire factory in 2020.
Oh, well,
Yeah, it's a different story, right? But to my point, in 1980 and 1990, we did a lot of, we were almost in the forefront of some of these things.
right. Then what?
Then basically, when our economic reforms were not as fast, or it was basically until 1992 we were not open, right?
Before the liberalization.
Right? A lot of hardships by these manufacturers back then to get a single machine. You just imagine, like, even after liberalization, there are a lot of issues going on with different departments, right? Like customs and stuff like that in a very recent time. But I'm sure we are going to solve those, right? Like the entire policy changes, we can see those policy changes, which is really good. But however, back then, it was very hard to get anything from outside the country, right? Everything needed license.
License Raj.
Yeah. So that is when the lot of factories were built, and they were importing a lot of chemicals that are needed to make these PCBs, right? What I see is by 1990s and late 90s, some of them have already started 2-layer boards, right? Back then, I can only imagine how hard it used to be, right? And some of them even started multi-layer boards in early 2000, right? So what happened after that? Why are we not in the forefront? So
Sorry, 1 second. So China became a leader after 2000?
After 2000. So China, almost, if you see, like, we would have seen a lot of videos where we know, like, China and India's trajectory was almost similar to a great extent until 1980, 1990 is when they started, it became very different, right? They went through a different era.
Right.
We went through a different era.
Right.
So we were very late. They were at least 10 to 15 years, or probably 20 years ahead, back then. And what really opened up China was basically the 2000, right? When 2000 happened. And India also, a lot of things opened up. In 2000, Y2K, a lot of service companies started in India. But China, basically, the manufacturing opened up, right? Like, especially in that early 2000, when most of the manufacturing from US started going to China, that is when a lot of technology, know-hows, right? Like I keep telling
From the US.
From the US,
right?
How to build circuit boards, how to build more complex circuit boards, right? How do we do these multi-layer boards? How do we now push the boundary, right? Like, can we do smaller holes? Can we do smaller tracks? So it's always about putting a lot of this density in a smaller area, right? A compressed version of this is nothing but a chip, basically. Even more compressed version of this is basically a chip, semiconductor. That's a different story. But However, in this, when a lot of these American companies started setting up units in China, it started exploding. They had a lot of demand. They had a big open industrial policies which allowed people to get into manufacturing, and it was a manufacturing rush.
Yeah, I mean, I remember reading like a couple of months back that Apple engineers or scientists were flying into China to teach them how to make things.
Yeah, that happens even today. That happens even today. So
you spent some time in China?
Yeah. So I've spent some time even before starting Lion Circuits. I used to work for a semiconductor company called Texas Instruments.
Right.
And Texas Instruments again is a very big public company in the US.
If you could give context on what Texas Instrument does or is.
Yeah, just a two-liner on Texas Instruments. Texas Instruments is a semiconductor company which builds analog and power, primarily focused on analog and power related semiconductors. Read as high margin business in semiconductor. However, primarily Texas Instruments deals with a lot of the semiconductor manufacturing. And I used to work for a sensor division there, where we used to build inductive and temperature sensing ICs, semiconductors.
Right.
And with that, I had to travel to China, interact with a lot of OEMs, ODMs, right?
Sorry, what's OEM?
OEM and ODM basically is original equipment manufacturers and original design manufacturers. So China, this OEM segment opened up hugely in that 2000 decade, right? When all these companies wanted to manufacture in China, they said, this is the product that I want. And since they didn't have any manufacturing capacity, they went and told how to set up the factory. They told, use these materials. They told, this is how you manufacture. They taught everything, right?
To the Chinese.
They showed every single thing to them on how to make it, right? That is when China's manufacturing evolution started.
Right.
So there, what happened was basically because of that huge.
Till then, they weren't even doing single layer PCBs.
They were doing single layer boards and stuff like that, but we were ahead of them for two reasons. One, during that time, we were net exporter of copper. India as a country, we were net exporter of copper. Today, we are net importer of copper.
Okay.
Right. But some of the plants that are coming from Adani copper plant is supposed to change again back to net exporter of copper.
But sorry, how did copper come into the picture?
So copper is one of the major thing for circuit boards, right? Because we use a lot of copper.
Okay. What's the like in a circuit board? How much?
Yeah, in a circuit board, right? You have only primarily at the end, what you get as a circuit board comprises of basically 2 to 3 materials. Major is copper. Like all your tracks, right, is basically through copper.
Right. The thing that you explained, copper sheets.
Copper sheets and stuff like that. The conduction from one place to another place, the wire connection is through copper.
Right.
And then to isolate the non-copper area, we use a non-conductive material. It's a glass epoxy typically, right? Typically a glass epoxy. So these are the main two raw materials. So copper is very important.
50-60% of the cost, I'm guessing.
Easily. So copper is a very important part. So back then, India was actually poised to grow in PCB. We lost that. We have to give certain credits. Like in 2002 and 2003, there were a lot of amendments made to Custom Act, which allowed importers of manufacturers to import machines without BCD, without, they also exempted, BCD is basic custom duty, which government charges, is basically basic custom duty, right? So the basic custom duty was removed in 2002 and 2004 subsequently, there are two important notifications which specifically gave PCB industry an opportunity to invest and grow the space. But in spite of that, we couldn't do. Mainly because the finished PCB could come to India without any duty also.
Oh, like I could, like if I'm a PCB guy, I could just
You can just buy from
China
from China
for a cheaper cost,
for a cheaper cost.
even if there was no BCD on the
It was not
base
yeah.
material.
It was not cheaper before, right? So to give an example, in 1990s, India went through this telecom revolution, right? We all would have used at one point a handset like a landline, right? So most of these landlines were manufactured in India, including the PCB.
Right. Single layer.
Single layer. So UTL, right? Like United Telecom Limited used to manufacture this. And their plant is what I was referring to before, which did the first single auto layer for single boards in 1980s. They used to use their own plant, manufacture these phones in 1990s. Right? That PCB plant shut down in 2020.
Because nobody.
Yeah, various reasons. So, however, like in so which means that in 1990, some of these phones that we were manufacturing, landlines, a lot of vertical integration. Plastics were done in India, PCBs were done in India. Most of the things that used to go in a phone set were done in India. We were already manufacturing in India, completely made in India products. So from there, in 20 years, right, or rather 15 years, we lost a lot of things to China.
Because everything went to China.
Everything went to
China. But what did China learn though? I get the cost part that, you sell it for a subsidized rate and, you get it for cheap. But what were the things that they learned that we don't know yet?
There are a lot of things. There are a lot of things which we don't know yet. It's not about money anymore, right? It's about technology. It's about the know-hows, right? Like I keep using this know-how, right? Know-how is very important, right? Just to give a small example before going back. Know-how, for example, what I say is, if somebody gives me 10,000 crore rupees today and say, okay, can you build a jet engine or a jet plane? Can you build a Boeing 777 tomorrow or like in the 6 months, or you take your manufacturing time? Can we build it? It's not possible. It's not possible.
I don't know how to put together. Yeah.
Yeah. So in simple terms, in 6 months or a year, So let's say Boeing takes 6 months to manufacture a jet engine. I will give you the same time, 6 months, right? And I will give you 10,000 crores. Can you manufacture a jet engine? Answer is plain simple, no. Why? Because there are a lot of know-hows involved, right? These know-hows are, some of them are, trade secrets in the form of trade secrets, in the form of just understanding how to do it, what to do, right? If everything is there, if design is there, even if you manufacture, there are certain processes that are involved, right?
Can you give an example? Also, one more thing you said, you can design, but you can't manufacture.
Yeah.
What does that mean?
See, basically, even if somebody designs, like let's say we have very good engineers, they can design a jet engine. Like let's say they can come up with some schematics and put together a jet engine, right? Just to manufacture everything, put together, make it work is a whole new story.
Right.
That is the most difficult part, right? Similarly, if you take any manufacturing, including PCB, there are a lot of designers, right? To manufacture those, there are a lot of know-hows. Know-hows, for example, what I mean by that is, so if today I want to manufacture a very thin track, can I manufacture a track which is 25 micron thin? Today I can't, right?
Why is that?
Because even though we have our own factory, our current limitation is we have pushed to around 75 micron. 75 micron track width we can do. That itself is very hard. 100 micron, it's okay, reasonable. Most of the factories in India can do 150 to 200 microns.
Right.
But at Lion Circuits, we can do 75 micron. But we learned over time.
Sorry, again, sorry, but what does it take to get from, let's say, 150, 200, 275?
Yeah.
Is it like I do?
Yeah, this is what I call as know-hows. So for example, it's not about just buying a machine and say, I'm going to use this machine and run the thing and I'm going to get. So these are all process industries, right? So in process industry, there are a lot of things like a lot of control parameters. Like for example, just to give a simple example, if you have this machine and let's say you have this particular type of chemical that you have used and you run it at a particular temperature, it behaves in a certain way. If you use the same chemical, if you change the temperature and you run the same board, it behaves in a different way.
Oh.
That is basically is the know-how. Only people who have done it, only people who know how to do it, know how to do it. Right? It's the know-how. So that basically puts us back. China got an advantage. Americans went and said, okay, this is how you have to do it. They did it. They learned.
Because someone was, it's like training.
Someone told how to do it, right? If somebody, like, that is basically the key knowledge that they gained, right? And they built on it, right? Whether they, how they did it is a different story, right? Like we all, used to hear
learning
copy and all these other things, but that's a different story, right? Like, but they learned a lot of things. Now, today, right, China is leading in all these things, not just that.
So leading in all these things, what do you mean by that? Do you mean designing to manufacturing everything or just manufacturing?
Manufacturing is, they are leading in manufacturing more than design, but they are doing a fair good amount of catch up on the design as well. And probably like they've already done, like,
where does the design sit right now?
Design, when you take design in a specific category, right? Like various categories have moved in a different way over time, but in certain categories, India has a position, like, of leading some of these designs.
Who does all of this?
Like, in general, like, even in like as a semiconductor ecosystem, right? Like in 1980s, the company that I used to work for, Texas Instruments, they set up a design house in India, right? Mostly design. So India today, India has a lot of design expertise they have built. So a lot of manpower, human capital who have built expertise of design in India have started multiple startups from TI. There is a lot of ex-TI companies. If you go and see like a lot of fabless semiconductor companies in India are mostly from ex-TIers. Mostly from ex-TI. Because
you learned the know-how there.
We learned a lot of design know-hows. We learned a lot of these things, which it's basically, I call it's a tacit knowledge. It's a tacit knowledge. It's also called as a tribal knowledge, which only when you are in the tribe, you will know that knowledge. If you're not in the tribe, it's very hard to find. It's not documented, right? So like this, basically, there are a lot of things in PCB, which is basically also know-hows and this tribal knowledge that exists. So that is what is basically is going to be a huge limiting factor, right? So coming back to I think we came to this discussion from we were discussing mainly about the PCBs, right? Like how the PCB evolution is happening in China. So I was giving an example of in China, in India, we have around 200 factories, right? We are trying to compare. And from these 200 factories in China, if you take Shenzhen and Guangdong province alone, there are around 2,000. I'm not even kidding, 2,000 PCB factories just in that area, around 50 to 100 kilometer radius of Shenzhen.
A province compared to the whole country.
Yeah.
It's 200 versus 2,000.
200 versus 2,000.
Yeah. And they're doing a bunch of, I'm guessing mostly HDI or...
Everything from single layer. They do single layer also. Toys.
Oh, yeah.
Huge toys, huge amount of toys. They do single layer, they do HDI, and everything in between, right? Huge factories, and nowhere comparison. Like the largest factory right now, as of today, the largest factory in India, probably not even come close to top 50 in China. Top 50 in Shenzhen, maybe.
Just a part of it.
Yeah, it's basically that huge, right? So that is the current state of Indian PCB manufacturing, right? So in summary, if you compare India and China, China is way ahead in PCB manufacturing. We have to learn a lot from them. We have to buy a lot of machines, chemicals, knowledge from them, and then build factories here, right? And it'll take time. Capital is one, incentives is one, but also learning this knowledge and building is yet another. So I was telling, right, like basically compared to PCB, if you take EMS, it is 3 machines: printer, pick and place, reflow. In PCB, you have 20 to 25 machines for one PCB, right? So that is where the EMS actually became, EMS growth was very high, mostly because very less complex.
But easy for anyone to get in. No?
Easy, no. Even like there, if you want to like control the process, have good machines, and do it, like it'll the barrier to entry is definitely low.
I thought it's commoditized. It's
Commoditized.
mostly
A lot of EMS. So EMS at least has a long tail. EMS maybe probably India has around 2,000, 3,000, more than 2,000 to 3,000 factories, EMS factories. Whereas like PCB,
is
less.
200.
Yeah, 200. That too.
That's a
Single layer.
percentage of.
Yeah. Like you like ideally you should like consider around 20 to 30, which can do like pretty good, like decent quality PCBs.
What's the roadmap for an ECB? Right now they are, let's say, assembling things. Which, like,
For EMS, right? Like
fancy packages.
yeah.
What's next for them?
See, for example, like companies like, all these public companies, right? Like Keynes, Sirma and all, they have large number of EMS lines. Meaning, so they have multiple units all around India. So it's about how many lines I have. It's about every day how many units I can, get out of the factory. Even Dixon, right? Like
Capacity.
Same. It's basically increasing the capacity, just running the same SOP that is there on
you
multiple
just need to put in more plants so that you can make more.
Yeah, exactly.
But like, what's the next step? Like, what's after assembly for them? Like,
So
I'm guessing you must have spoken to some of these guys, or
yeah. And in fact, we line circuits we also do assembling. We also have an SMT line.
Right.
Right. So basically, after that is contract manufacturing, ODM, right? ODM, OEM. So building your own products or helping white label a product. So like for example, Foxconn and all, right? They're purely like they're very focused on a couple of businesses and OEMs and OEM opportunities. They only do OEM opportunities, right? Keynes is basically also doing that. Dixon, for example, they do a lot of washing machines, and stuff like that, right? So they're all like basically OEM. They're OEMs for a lot of these big brands, right? So like for example, if you take Samsung or any other washing machine or brand, right? They might work with one of these players to get the entire unit assembled, not just PCB, but the entire.
But they white label.
White label it, yeah.
Yeah. So one thing that you had mentioned was that we were copper net exporter, but why was that? Why did that happen, and what's the relevance now?
Yeah. So basically, as a country, we were net exporter of copper. Basically, what it means, we were producing copper more than what our local demand was, our domestic consumption was. So the remaining we were exporting. So when the Sterlite plant closed in Tamil Nadu, right, because of
Sterlite plant was the biggest,
one of the largest copper plants in India.
If you could put it in percentage terms, how much of the copper being produced in India was?
I think from what I can recollect, they were producing about 30 to 40% of India's copper needs were being done from Sterlite plant in Tamil Nadu.
Right.
When the Sterlite plant in Tamil Nadu closed, post that, we became net importer of copper. Meaning, right now, combined all the plants, we are producing less than what we need, which means we have to import copper from other countries to even do anything. Like, so, for example, there are a lot of CCL,
What CCL, sorry?
copper clad laminates, which is basically the raw material for making a PCB, right? So, with the latest government schemes, which are targeted towards bringing up the PCB industry, there is a scheme related to CCL as well, which is copper clad laminates, right? So when we do these copper clad laminates, until some of the new plants like Adani plant in Gujarat is fully functional, we'll still be importing a lot of copper from China, for example.
So this was also a barricade. This is also one of the barricades for us doing PCB manufacturing, because copper is a
This is very big.
cost goes up.
Yeah. So right now, for example, as we speak, there is almost like a 10 to 20% increase in raw material CCL prices just from last month to this month.
Because of the import cost.
Because of,
But what's happening? Why?
Right now, it's mostly because it's driven mostly by USD,
The rates.
the rates, the foreign exchange rates, and also, see, basically the entire this
This we are recording in October, just so that,
So the entire PCB industry is, the costs are controlled by these raw materials, right? So who is making these raw materials? China. So we are heavily dependent on China for a lot of these raw materials. That is where government has come up with a lot of incentives and schemes towards building a robust raw material ecosystem in India.
The base materials that are
Base
required
materials
for PCB.
that are required for PCB. Chemicals. There is a...
What chemicals are needed?
So for what chemicals are needed?
Like chemicals as in, what do you need the chemicals for? Like,
so because as I said, PCB, to make a simple PCB, we need around 20 to 25 machines to process the entire PCB, right? So bulk of these are wet processing machines.
okay.
So these wet processing machines, meaning that they are driven by chemicals. So photoresist, wet process. Dry plus wet. Etching, fully wet process. We have electroplating, that is fully wet process.
Right.
So these processes need specialty chemicals, right? So unfortunately, though there are a lot of chemical engineering colleges in India, we don't have good electrochemical recipes that are needed for PCB, which are locally made. There are some companies from Germany and Europe and America blending those chemicals and manufacturing some of those chemicals in India today, but there is no Indian company. There are very less or no Indian company who can do very high quality made in India electroplating chemicals for PCB. So government is also promoting in the recent electronic component manufacturing scheme, which has been in the news in the recent time.
The ECMS
scheme has a provision for starting chemical plants, chemical blending plants, which is one of the important raw material for these PCB industry.
But that will take some...
It will take time. It'll, again, it's a lot of know-hows and, processes and stuff like that.
Right.
The other important material, so you have chemicals, you have metals, like the copper as a metal is also used. Like in copper plating, we use copper, just pure copper as a anode for electroplating. So mainly PCB, raw materials, chemicals, metals, laminates. So laminates is also another area which is targeted in ECMS scheme. Right. So some of the big companies, like including Wipro, has committed
500 crores.
500 crores, to set up a CCL. So it will be very interesting whether those plants are done to serve domestic consumption also, or are they only targeted for exports? I wish it is also for domestic consumption, because then I think we will have a lot of control over the price, and hopefully the price comes down for the laminates. The CCL is one of the biggest contributing factor for
50-60%, whatever we discussed is
yeah, around 30% at least.
Now that you've spoken about India, I mean, it feels like a good note to end on.
Yeah.
I still don't know if India is at the right place to do PCB right now, because of the lead that China has had.
Yeah.
And that will continue to compound, I'm guessing. We're starting from just knowing the know-how.
Yes. Yeah, definitely. I think right now, as of today, we are not in that position, but we are heading in the right direction. As an industry, we are rapidly growing in the direction of building high quality printed circuit boards from India. And I also wish and use this opportunity to any viewers out there who want to build factories. Please go set up, figure out how to build PCB factories. We need hundreds of them, probably thousands of them in the coming years, because for all the electronic manufacturing success stories to come out, we need PCB factories, right?
Well, that's the base.
That's very most one of the basic thing, and the most important thing also to kind of innovate and drive some of the product companies forward.
Okay, thanks again for doing this. I had a lot of fun, but I'm still confused about a lot of things. So maybe we'll do this again sometime.
Yes, thanks for having me.